everyone, Katrina here, and today I'm going to show you how to factor high-order polynomials using synthetic division. Make sure to subscribe for more videos like this and watch to the end to see the full example. Okay, so when we're factoring high-order polynomials, there's a few things that I want you to keep in mind before you dive in. The first thing that you want to do is check out remainder theorem. So if we have some polynomial p of x, for example, and we're considering a root called b, so we'll say that b is our root, we want to check, does pb equal to 0? Okay, so if we plug in some test root that we find, let's call that b, into our polynomial, we want to see if it equals to 0. If it does equals to 0, so if p of b equals to 0, therefore, by the factor theorem, we have that x minus b is a factor of our p of x. Okay, let's talk about that once more. So we have a polynomial p of x. We're testing some value b. If p of b equals to 0, then x minus b is a factor of p of x. That means we can then divide our polynomial by this number, by this factor, and we will get 0. So that's the first step. So once we've determined our root in this case, and we found our factor, then we can perform synthetic division. So that's the first part. So we have the root, we then do synthetic division, and then as a third step, we have to continue to factor. So if we have a very high order polynomial, we might have to perform this process multiple times. We might have to go through finding a root in many stages if we have a very high order polynomial. And then we continue to factor, and finally at the end we should end up with a quadratic, which you no longer have to use synthetic division before because you can use our other factoring tricks that we know for polynomials. Okay, that was just a mini pre-lesson, so I want to go into an example that will help clear up all of this. So we're going to consider a polynomial, so write p of x equals to x to the power of 4 plus x to the power of 3 minus 13x squared minus 25x minus 12. So what is the degree of this? Well, the degree of the polynomial is the highest order of x. So in this case, our degree of this polynomial equals to 4. So 4 is considered like a high order polynomial. So we're going to go ahead and use the Rational Root Theorem, which I have a video on already, to determine what are some potential roots of this polynomial. So we're going to go ahead and just try some. So we're going to try p of 1. So p of 1 gives us 1 plus 1 minus 13 minus 25 minus 12. Well, this does not equal to 0. Good try. Let's try another one. What about p of negative 1? We get over here 1 minus 13 plus 25 minus 12, and hey, that equals to 0. So that means, okay, what does that mean? So that means that negative 1 is a root, okay? And if negative 1 is a root, we know that x minus root is our factor. So that means that in this case, we have x minus negative 1, which is equal to x plus 1. So x plus 1 is our factor. So that means that we can divide our polynomial p of x by x plus 1, and we will get 0. So now we're going to follow step number 2, and we're going to go ahead and do synthetic division. So for synthetic division, the first thing we have to do is put our factor into this top corner. So we're going to put in our negative 1. And then we want to collect the coefficients from our polynomial and put them in a line. So make sure to include all of them in the correct order. So we're starting from the highest, so highest degree. So we have 1, 1, negative 13, negative 25, and negative 12. Okay, so when we perform synthetic division, we start at the leftmost side. The first thing we do is we drop down our first variable, or first number. And then from there, we're going to multiply it with our root. So we have 1 times negative 1, and that equals to negative 1. We're then going to add downwards in the column. So we're adding down the columns. So then we have 1 plus negative 1, which equals to 0. We're going to do the same process where we're going to multiply it up. So then we get 0 times negative 1 is 0. Negative 13 plus 0 is negative 13. Let's multiply that up again. Negative 13 times negative 1 is just 13. Negative 25 plus 13 is negative 12. Another time multiplying up. Negative 12 times negative 1 is simply 12, and negative 12 plus 12 is 0. So this absolutely has to be 0, because that means that our remainder is equal to 0. And as it should be, because we said that p of negative 1 equals to 0, and we've already determined that this is a root and x plus 1 is a factor. Great, so now that we've done this synthetic division, we knock off 1 degree of the polynomial. So we start with degree equals to 4, and now we're going to have that degree equals to 3. So we need to collect all of these numbers on our last row, and they become our new coefficients of a cubic or degree 3 polynomial. And we have to make sure we keep our 0 there as a placeholder. So now we have x cubed plus 0x squared minus 13x minus 12. And this is our new polynomial that we need to continue to factor. So we can rewrite this then as x cubed minus 13x minus 12. And we're going to have to go and perform synthetic division once more in order to factor this. So we have to repeat the process and find our p of b such that p of b equals to 0. And so we can go ahead and we can try all the different options here. So since we have negative 12 here by Rational Root Theorem, all the options we can choose are our plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, and plus and minus 12. These are all the factors of 12. But I'm going to let you in on a little secret, is I've solved this problem already. So to save us some time and go through all these, I'm going to tell you that negative 3 works, but we'll prove it. So p of negative 3 is going to equal to negative 27 plus 39 minus 12. And we can see that that equals to 0. So that means that, what does that mean? Negative 3 is a root, and then x plus 3 is a factor. So we can now use this information to perform synthetic division once again. So again, we have to put our root in our top left corner and put all the coefficients that we have. So remember, we have to keep our 0 over here as a placeholder. So that means that when we do our synthetic division here, we have 1, 0, negative 13, and negative 12 as our coefficients. So let's go do this process again, a little bit quicker this time. So we're dropping our first one, multiplying up, so we get negative 3, and remember we're adding down the columns. So we're going to do this again. So here we get 9 minus 4, multiply up, which is 12, and 0. So that means we've done it correctly again, because our final remainder here equals to 0. And so again, we ended up with a polynomial of we had a polynomial of degree 3, and now we're going to knock off a degree and end up with a polynomial of degree 2. So that means that we're going to have these coefficients over here, this 1, negative 3, and 4, are going to be our coefficients of a quadratic equation. Therefore, we have x squared, or 1 times x squared, minus 3x minus 4. And we can just use our product sum rule. So I encourage you, if you need some help with factoring, I have many videos done on factoring. I also have a full factoring crash course to get you completely up to date. So again, please subscribe if you want to stay up to date with these videos. Okay, so here we can see that our product equals to negative 4 and our sum equals to negative 3. So what two numbers multiply to -4 and add to -3? So we can see that 1 and -4 work in this case. So that means that this is factored as x plus 1 and x minus 4. Okay, you may think that we're done, and we're basically done, but we can't stop here. We have to recall all the other factors that we found initially. So the first factor that we found in this process was our x plus 1 from our first round. In our second round, we found, what did we find? That was our factor. So we had x plus 1, and then we also found that x plus 3 in our second round was a factor. So those are from our first two rounds, and then our last round here we have x plus 1 and x minus 4. And this equals our p of x. So let's go ahead and simplify this or combine it. So we have two terms of x plus 1. So that means we end up with x plus 1 squared, and then we have x plus 3, and then lastly x minus 4 equals to our p of x. So let's take a deep dive into polynomials just to understand their features a little bit better. So we see that this term here has a degree 2, and these two over here have a degree 1. So this means that the order, or it's also known as multiplicity, that equals to 2. Over here, the order equals to 1, and our last one, our order is also equal to 1. So you would say that we'd have here a root of -1 with order 2. Second one, you'd have a root at -3 of order 1. And lastly, you'd have a root at 4 with order of 1. So when we have an order of 2, that usually means that your root will bounce off the x-axis. So say over here at -1, and we're just looking at this independently, x plus 1, for example, or x minus 1, that means that our root is actually going to bounce off the axis. So that means that we have a double root. So you can think of our basic quadratic equation there. Sorry, that's a bit shaky. Where when we have an order of 1, I want you to think of more like a linear function type setting. So in that case, of that root, that usually means that the function will just pass straight through the point. Same with over here. Maybe at 4, it's just going to pass right through. So it's just important to understand kind of the relationship between double roots, single roots. What does it mean, especially when you're looking at polynomials of higher degree, so that you can really break down the polynomial and understand the local behavior at each one of your roots. Okay, so that is all for today. We successfully factored a high order polynomial of degree 4 into its individual factored terms. And then we analyzed the order of each of these terms and understood what it means graphically. So if you enjoyed this video, please drop a like and comment any questions that you have. And please subscribe for more videos. I've got tons on factoring and all different levels of math, and I look forward to seeing you soon.